Hello, everyone, and welcome back. I hope that you had some nice meals and some nice photos and some nice discussions. So we are here in the third day, going over more technical stuff, and especially about oracles and how they can unlock new possibilities for developers and applications and what they can bring it. I am here with Philippe from Umbrella, Faisal from Entangle, and from Hatom is Ramirez. So let's give them a round of applause, and everybody should introduce themselves.
Hello. All right. Hi, everyone. My name is Philippe Engels. I'm head of partnerships at Umbrella, a decentralized Oracle that is currently deploying on MultiversX. We will go live sometimes in the next few days, and we're very excited to be part of this ecosystem.
Hi, everybody. So my name is Ramiro. I work in Hatom as a head of engineering. And probably some of you know the protocol. It's a big protocol already in mainnet, composed of lending and borrowing and liquid staking solution. And yeah, the team and I have been building stuff in Multiverse for the past year and a half, and keep building here. So glad to be here, right?
Hello. Oh, it's working. Yeah, so I'm Faisal. I'm the CEO and founder of Entangle protocol. So we're an infrastructure layer composed of an Oracle solution supported by a modular blockchain. And the goal for us is to unify Web3 with customizable and secure cross-chain communication. And alongside our our infrastructure, we have our native dApp, which is called Liquid Vaults. And what it looks to do is optimize liquidity within different ecosystems by unlocking the utility of yield-bearing assets, in particular LP tokens. And we've already connected to MultiversX on our testnet, and here we are enjoying the lovely xDay.
All right, thank you, Juan. So thank you, everyone. As we are talking about oracles, the first question is why we need oracles and why they are so important into a blockchain ecosystem.
Go ahead, please.
All right, so I think I explained it yesterday in my presentation, but blockchains in general are a closed ecosystem by design, so they don't know what is happening in the real world, and this critical data that can be used to enhance the use cases on the blockchain need to be brought on-chain by the infrastructure that is the Oracle. And our mission is to make it in such a way that it is secure, that it is validated, and that smart contracts can operate and automate their functions in a trustless manner.
So following that idea, I mean, for our case, practical case, we use an Oracle for the lending protocol. The most important interactions that you can do with us are borrowing, also withdrawing collateral, and liquidating a position or an account. And those three interactions need pricing, token pricing. So are pretty critical. If we don't have a reliable price, and someone, for example, takes a borrow from our protocol, he can be stealing funds, you know. So the pricing, I would say, is on the top list of things important in the lending protocol. Not in the liquid staking solution, but yes, in the lending. So,
yeah, I think the guys here obviously explained it very well, but I can just give a very basic example. So blockchains, as Philippe just said, are quite isolated. But when you have the smart contracts associated with them for events-based execution, so for example, myself and Ramiro get into a contract to say it's going to be warm in Bucharest tomorrow. Ramiro says it's going to be cold, and we put $100 each into a smart contract. That's relying now on data to confirm or affirm who is correct within our sort of speculation that we've just done. And oracles are then utilized to bring that data, obviously securely, and we'll go into that in the next questions and how that's done. And then, of course, if it's warm and I win, then I'm very lucky and I get $200. And if it's cold, then, of course, Ramiro walks with the cash. So I think oracles are very central to open up a multitude of use cases and to expand smart contracts and ensure that Web3 can really, evolve to the next stage.
So, sorry, in the Oracle, what you are saying is that not only pricing is possible, but, for example, saying in the blockchain that, yes, tomorrow actually was hot or cold or whatever. So
yeah, absolutely. So that's just one example, obviously, but it can go to real-world assets. It can go to tokenization of assets. There's just a whole expansion of use cases that can be extrapolated, and that's why having the right Oracle solution is one of the most important choices an application or a blockchain ecosystem will make.
All right, thank you. Thank you very much. And after that, let's delve into more harder questions. So oracles have been in the crypto space, I think, from 2017, 2018, when the EVM started to grow and a lot of projects went there. But there were some problems. There were some pitfalls there that like data irregularities or oracles not pushing data fast enough, and because of this, some people might have lost money or lost tokens. What are the pitfalls of Oracle development, and how do you manage such things? This is for the two guys developing oracles, and for Hatom especially, how are you working, or what are the guarantees you offer when, for example, Oracle data you might seem incorrect or not reliable or things like that, as it was in the space. I think last time it was when Terra Luna went down and USDT or not, the UST went down. Then there were and a lot of protocols. They had a lot of issues with that, from not only from Ethereum but from Osmosis, I think. And then what are you doing in that kinds of cases? Because as always, we are in the blockchain. It's okay and easy to develop for the 95% of the cases, and then for the last 5%, you spend another year.
Yeah, in general, oracles are a tricky business from a cost perspective. Initially, when you say that the data availability was low, this is related in general to the push oracle model that was developed initially by Chainlink, the industry leader. And because every single data point needs to be written on chain once at a time, on Ethereum back then, the more you write to be more accurate, the more expensive it gets, and one data point at a time. So you multiply this by the number of data points that you want to have on the blockchain, and this becomes very, very costly. So that's why they have those deviation threshold in the heartbeat to have some sort of buffer or acceptable changes that protocols can actually work with in order to save cost on the, when you push oracles. So I see that all the new oracles that are coming to market, they are usually pull-based oracles. I do think that the industry is going to move towards pull oracles at some point, because there is also a way to shift the cost to the end user if it is a pull-based oracle. If you can include this in the transaction cost, then there would be no cost to the protocols themselves, and you could get this on demand. So the cost of oracles is very very important to take into consideration, and then the transaction cost on the blockchain, that sometimes you try to push data when there is high transaction fees and the transaction fail, and then you try again. So those are issues, technical issues that are inherent in the technology that made those issues happen. And sometimes, I mean, we've noticed that Chainlink didn't push the UST data for a certain amount of time, because they could kind of regulate whether they do it or not. So that's also one of the aspects that we have to take into account. Who are we trusting? Is it decentralized? Is it one person that could actually switch it on or off? So there are many challenges to overcome. Everyone is offering different solutions, and yeah, so we're just all here in the market to innovate, to push the Oracle business forward, the technology, and to create safe solutions for smart contracts to use.
Yeah, great explanation there. I think really, of course, varied sources of data always help to ensure that there's accuracy and consensus there. So how we're doing things is quite different, actually, and really one of the things that we are really focusing on is data integrity. And of course, we're working with Hatom as well to build out some very interesting use cases. One of the examples that I want to give is, an oracle is quite a broad term, so you can even fetch pricing from a DEX, and that could be constituted as an oracle, potentially. But really, an oracle, the word oracle, I mean, I'm sure we've all seen The Matrix, and the oracle should be all-seeing, all-knowing, all-connecting. And that is something that we're looking at trying to achieve from a cost perspective as well. But if I give you an example of Sturdy Finance, they recently got sort of front-run and manipulated, where a lot of money was stolen, because they were accepting Balancer, which is a kind of a DEX. They're using their LPs as collateral, something that we're doing with liquid vaults. And really, they suffered because they had one source of price collection from a DEX. Whereas Entangle addresses that by having multiple parties involved in consensus, multiple sources, so we can combine VWAP, TWAP, time-weighted price averages, volume-weighted price averages, and combine price feeds from multitude of sources, and then have multiple parties validating that data, storing it, or confirming the consensus on our blockchain, and then we have keepers that go and deliver that message to the said DApp that's requesting that. So one of the key things is data integrity and how you deal with that, and I think you need to have complex mechanisms and variety of sources to combat that, number one. And number two, in Entangle's case specifically, as we're trying to unify Web3, we need to really go to different blockchains and deliver data. And it's very, very important that we get the consistency of communication right. So recently we built out our smart contracts on MultiversX. Now it's a non-EVM chain. We also connected to EVM chain. So having uniformity in your web of contracts so they all can talk to each other, they all can then obtain consensus and execute events is very, very important. So, and then, dealing with cost efficiency is obviously very, very key. And that is a particular reason why we have a modular chain specifically designed to support the Oracle solution. So it's not ingested by 1,000 applications doing other things and then doing Oracle transactions or validity of Oracle information at the same time. So it's really design choices are very, very key when dealing with Oracle-related activities.
So from the point of view of the technical implementation in Hatom, what we did was actually, and it has been performing really good. We have like many machines running different parts of the world and pushing prices from different sources like Binance, CoinGecko, CoinMarketCap, and so on. They push prices to a smart contract that we have, which is called the price aggregator, okay? Then we also have the exchange, the X exchange, as a source of pricing. And in the X exchange, there is something similar, really similar now to the time-weighted average price that we can fetch as well. So we have two different sources of prices. Those two prices should match within a tolerance to have a successful transaction. Otherwise, if they differ like from a first tolerance, we call it, the transaction will revert. Actually, not the first one, but then will revert, and will keep reverting until they go back to normal. But there is another edge case in which the prices are too different and they surpass another threshold. The transaction not only will revert, but the token pricing will be paused and will require admin interaction to unpost the token. So there are 2 layers there for security. We haven't seen any surpassed yet, but it's pretty good design. If we compare with other oracles out there, they have, like in Compound, if you look into the smart contracts, they don't use this kind of approach. It's a little bit simpler, but in our case, since we couldn't rely on another provider like an oracle already deployed yet in the blockchain, we decided to go as safe as possible. Okay, so yeah.
I pretty much like that approach that you are protecting the users by these kinds of pause or reverting, even though you could help, let's say, the liquidators, but protecting the users, I pretty much like it and their funds. That's one of the things some of the lending protocols do not do, because they said that liquidators are so important. They are important, but in case of crisis or in case of errors, I think it's good to go and protect the funds, actually, and then it will sort out. So it's great to see that. A little bit, the next question, it was about like, how can projects come to Oracle services and work with you, and how can ask about like new data. And this, I was especially about like what you said, that push versus pull. I think we have to define who pays who in these kinds of scenarios, because if a user want to lend or want to liquidate or want to do kinds of things, and I do have to pay for an oracle as well as the protocol to do something, I think it's complicated. And I think even, for example, from a front-end perspective, it's pretty complicated to, okay, then I have to, if the price is old, then I have to add another action into the user transaction to pay for the workers. So how are you approaching the pull method, and after, so when, and how much after a pull or after a request, how much data are you providing? And then how can projects out there approach each one of you in order to use your data?
So right now on MultiversX, the one that we are deploying is the push, because it is still industry standard. Many, in general, smart contracts prefer this version, so they go, they read, and execute. However, we have another solution, which is also a pull solution. It's what we call our data roll-up. So we aggregate thousands of data points into a Merkle tree that we secure on chain, and then the way it would work in this case is that the project, whenever a transaction is triggered, they would call our API, verify, the data point that they need, the asset pair for the trade. Then there is Merkle proof that needs to be done on chain, so they inject the data in the blockchain, the Merkle proof is run, and the result, if the result is true, the data is safe to use and then is included in the transaction to use. So that's one way to do this. This is a specific use case for our roll-up solution when you need large data sets, but this is not the on-demand. The on-demand is a solution that we're currently working on right now. The way that we imagined it is that whenever a transaction happened, we would receive the message, we would fetch the message, run consensus on the data, and then we have a module that's called Passport that delivers the data straight to the smart contract. So the idea is to include this action within the transaction, so whenever this is triggered, then this process happens and delivers the data to the smart contract. But this is something that is still in conception. We hope to give you more details in the future, but I think Entangle and their keeper have a different approach to delivering data.
Yeah, actually, it's a little bit similar in terms of how we're looking at sort of consensus with the blockchain. But really, what we're looking more at Entangle is customizability. So you can deploy your own keepers as a protocol. You can create custom price feeds. So, for example, we have price feeds that are multi-chain. So we're obviously an interoperable Oracle solution with price feeds that are spanning across different dexes. And we can even pull from sex pricing, of course. But what we're trying to do is we provide a standardized set of price feeds that you can enact, but you can also then define and customize your own price feeds and your own keepers, which are essentially vehicles that delivering data to your application. And in terms of fees, we're still in testnet at the moment, so we're really looking at percentage fees, based fees, trying to see what is a cost optimization method that we can achieve real efficiency with cost. So that's how we're looking at it from a customization perspective.
So from my side, just one comment. We don't have a business model, like we are going to become clients of you guys probably. The idea, we have already two sources of prices, the price aggregator and the DEX, as we mentioned. And if we add another source of pricing or two more, then we can have like something, if price match in 2 of 3 or having something like that, will give us a high availability, and it will be pretty much more secure.
Yeah, absolutely. So that's what we're trying to do with the customizability. So you can customize parameters like that, because certain transactions will require a lot more data integrity or reducing the chances of any ill occurrence. And where you have high value transactions or something that's very, very significant, then you can customize such parameters and ensure that even for example, you have an institution in the real world that wants to bring a stable coin onto the chain. I think there's this notion of these Web3 keepers and these Web3 validators. Who are they? Even though we're going to be running KYC on our keepers and validators, it may just be that they want to deploy their own set of keepers, so like a hybrid system, which then becomes very secure because their keepers may even be centralized keepers that they want as a first point of attack, and then combine that with a secondary layer of keepers, which are the Entangle keepers. And then they can take this stablecoin to 7 different chains that Entangle's connected to, with various different types of logic that they can customize. So that's how we're looking at use cases, because not everything, one of the problems that we foresaw when building Entangle, and really the Entangle, the genesis behind it was liquid vaults, the DApp, because we saw that, just for LP assets, there's just not enough incentive there or utility. And when we looked at certain Oracle solutions or previous Oracle solutions, we realized that we can't simply operate a one-size-fits-all policy. It needs to be configurable, it needs to be flexible, and that's why we actually built the Oracle, really, because it was there to support a very complicated application, and we just felt that that wasn't possible with other solutions that were there at the time.
So I remember, Robert, you asked me a question a while ago, if we could add LP tokens to the lending protocol. And in Aave, I think Ahmed told you that they removed them. Maybe that's the case, like pricing for LP is not like...
I would not necessarily go to LP because, LP, but farm as well. Okay. It's because then you could earn in a more way, and you would use the liquidity from one protocol to another. Yeah. And I probably there are the limitations of pricing and all kinds of stuff on Ethereum is are much higher than in MultiversX, because data, transactions, and everything cost much more. So I would say that even building oracles is a little bit safer here. I do not know how many minutes. We have 3 more minutes, so it's great. But how I understand is that, and how I saw is that a lot of the dApps, like you like the data to be already available, not to request for it. So, and if you want data to be already available, so it has to be some kind of prepaid mechanism, I think, because the oracles and those machines have to run, and so you have a running cost for it, and such kind of machine has at least $100 or $200 per month running cost. And then you have the cost of transactions. So how is it sustainable for oracles to do still push, because you, as a smart contract developer, you would like to have the data already there, let's read it out, but for you to be still sustainable?
I mean, in our case right now in the push solution, it's pretty straightforward. So we cover the cost initially, and we then have a fixed cost that we charge per number of updates. So you need 2 updates, 2 feeds updated. I mean, this depends on the deviation threshold and the heartbeat that you set, and then you pay a certain fee, and you have to cover for the transaction cost. But in our case, we pay this up front, and then at the end of the month, we send a report to the customers, and they pay. And if they don't pay, then we might have to switch off the feed. But yeah, so that's how it works. It's not ideal, but yeah, this is the way it works. And I think this why in the pool it might be easier to monetize. And one point as well, because once we write this data on chain, so we might charge the first customer for it. But once it's on chain, everyone else can read it. So this is, I would like to see kind of a function where whenever someone reads, there would be a small fee to be paid, and that would then go to our validator network.
I want us to say that this is possible in MultiversX. So
Very good to know.
You can make your smart contract non-readable, and that actually means that every data, every view function which they want to get some storage out, they actually have to execute your contract. So there you can charge it.
Very good.
So I'm just saying that this exists on MultiversX. I know it's not exists on other chains, but you can use it.
Yeah, so in our case, I mean, just on that point on the LP stuff, is actually we issue LSDs, so we make the LP work, and then we issue an LSD, which then can be collateralized for further lending and borrowing, supported by our Oracle solution. But in terms of our economy model, we realized very early that, you know, there's problems with inflation, and you have to bootstrap initially. But that's why we're very focused on building applications that are native to Entangle, that span cross-chain. For example, liquid vaults, which is the LSDs of underlying LP positions. So we're building a mini economy for our keepers and validators to partake in already. So that sort of helps us, because idle assets and unlocking utility of idle assets is a very, very large market. It's like an entire refinancing market. And if that is not secured and that is not developed within Web3, then you really don't have incentive for liquidity providers. And you really need to incentivize liquidity providers and offer utility on these assets. So by doing that and optimizing, for example, MultiversX liquidity within the ecosystem, a lending and borrowing solution can now talk to AshSwap, a DEX, for example, and optimize liquidity intra-chain. We're already making some bread and butter for our keepers, and that is something that we're looking at doing, because an Oracle cannot, you know, if it's just inflationary economics constantly revolving and it's not busy and it's not operating, then is it really efficient? And that's what the thinking behind liquid vaults is as well. So that's an approach that we're taking, trying to create mini industries for our machines, and it's proving very successful thus far.
Our time is up. It was a nice talk here, and we can continue on later outside, but for everybody who needs oracles, here are, just connect with them, and let's continue building it. Let's learn from each other and build new products as well. An applause for the builders.
Thank you.
Thank you.